Alrighty, so we're working on section 10.2 today on multiplying polynomials together, what we call the double distributive property. Now, when you're taking notes, make sure that you have a pencil that's good and has a nice sharp lead, because writing with a pencil that has a broken tip is pretty pointless. That one wasn't great. Alrighty, so we're going to work on the review here. Now, once again, pointing out that all exponents are going to take a step down. So we have x squared and x to the fourth means we have x times x times x times x times x times x, which means we have 6 total x's. We just add the exponents together. Here, because that's an invisible exponent, or as 1, this ends up being y cubed. And down here on the bottom, these both have invisible exponents, so it's c squared. Okay, that's an important thing to remember when you're working through these problems. So the distributive property, the old way, was pretty simple. If we just had, let's get blue here, we just distribute the 3 to both terms. So this would end up being 3x plus 12. And since that's all we have, we can't solve for x. We don't need to do anything. We are just simplifying. Okay, not solving, just simplifying. Down here we have an x involved, so we end up getting 5x times x will be 5x squared, because of the same rules that we had on the first page. And then over here, 2 times x is going to be 2x. Okay, and down here on the bottom, by far the toughest problem, we end up having the 3x and the y squared and the y squared and the 2. Well, this will look interesting here once you see it, but it could be 3x y squared. Since they can't combine, they're apples and oranges, they're just going to simply be multiplied together. And what's interesting here is this is a variable, meaning you could also write this as y squared x or xy squared, but they can only combine with other xy squareds. Okay, so if you have yx, that can't combine with y squared x. It's just a new variable. It just represents just like x and y and c and d, something like that. Well, finally, we have the y squared multiplied by the 2, which gives us 2y squared. Okay, so if we move on to the double distributive property, or the FOIL method, FOIL represents first, outer, inner, last. Okay, I don't use the FOIL method, but I'll show you what it looks like, because a lot of other teachers do. The double distributive property means if we have 2 parentheses set together like this, the goal is to get rid of the parentheses. Okay, important to remember, the goal is get rid of parentheses. Goal is to get rid of the parentheses. Now, to do this, we have to distribute the x into both terms, which is what I did down here, and we also have to distribute the 4 into both terms, meaning every term in the first parenthesis needs to get multiplied by every term in the second parenthesis. So what we're doing is we're distributing in the x and we're distributing in the 4. Either way to do this is just fine. I do it the top way, but there are some students who really like rewriting it as the separate on the bottom, which is fine. So what we do is we take this x and we're going to distribute it to both terms. So x times x is x squared. X times 2 is going to be 2x. And we're done with the x. So then 4 times x is 4x. And 4 times 2 is 8. Frequently with the double distributive property, you are going to be able to combine the second and third term. So we have x squared plus 6x plus 8. Now, first, outer, inner, last, or FOIL means you take the first 2 terms, 1, 2, and you multiply them together. You take the outer terms next, which is here, and multiply them together. Then you do the inner terms, here, and multiply them together. And then the last terms, here and here. Okay? I don't like the FOIL method because you're doing the exact same thing as taking every term in the first and multiplying it by the second. But if you think the FOIL method makes sense, easier to remember, by all means, go ahead and use that. So here's an example. I want you to try this on your own. Okay, so let's see how this went. We take the d and we distribute it into both terms, or the 2d, and then we take the 1 and we're going to distribute it to both terms. 2d times 3d is 6d squared, because d times d is d squared. 2d times 1 will be 2d. The 1 now gets distributed to 3d, and that's going to be 3d. And the 1 gets distributed to the 1, that'll be 1. Now we can combine the inner terms. We get 6d squared plus 5d, because we're adding, plus 1. And that's as far as we can go. We can't solve, we're just simplifying. Okay, let's try. Now we got some negatives involved, so let's try this one. Okay, let's see how this one went. So we're going to distribute in the 9w first. 9w times 3w is 27w squared. 9w times negative 3 is negative 27w. Now we distribute in the 3. 3 times 3w is 9w. And 3 times negative 3 is negative 9. Now we can combine the middle again, but we have to be careful. It's negative 27w plus 9w. So that means our middle term is going to be negative 16. That's not right. Negative 18w minus 9. Okay, and that's as far as we can go. Now here's why I don't like the FOIL method. The FOIL method doesn't work for terms like this, but it's still the same concept. We are going to take this 3z, whoops, and we are going to multiply it times each term on the inside. Okay, so 3z gets distributed here, here, and here. And then the 1 also gets distributed here, here, and here. So this will take a little while, but that's okay. So we get 3z times 2z squared gives us 6z cubed. 3z times negative 3z will be negative 9z squared. 3z times negative 9 will be negative 27z. Okay, so now we're done here. The 1 gets distributed here to be positive 2z squared. Then negative 3z, and then negative 9. Now we have to look at the cubed term first. There's no other cubed term, so we keep it as 6z cubed. Then we look at the squared term. Looks like we're all in here. Now it's negative 9, positive 2, so we get negative 7z squared. Then here we get the regular z terms, negative 27, negative 3 combined together to give us negative 30z. And then the leftover is negative 9. And so that's our answer right there. Now, last problem. The reason why we do stuff like this is if we're given a football field, we have here, and we don't know necessarily what the length and the width are, but we know the shape that it deals with, we can use this type of formula to solve it. Now, area formula is always going to be base times height. And here the problem is our base is a variable or an equation, and our height is also an equation. So we have to multiply these two things together. So we get 2x plus 2 as our base down here. Whoops. And we get our height is going to be 3x plus 1. And now we just simply multiply them together. So I want you to try that. Alrighty, so let's see how this went. We should have distributed the 2x first, and then the 2. So we should have gotten 6x squared plus 2x, and then we should have gotten 6x, and then 2. We combine the middle terms to get 6x squared plus 8x plus 2, and there's your answer. Alright. Here's the problems. We're going to work on those in class tomorrow. Have a great night.